So what we have done is, we proposed a model like this. Okay, it's a very simple model. I know that most of us would have stuck with this model in the very olden days. That it had a user, it had a server. The server had everything: the app server, web server, database server, everything bundled together, and then we provided the solution. Okay, look, take it, and you can start working with now, and you can start monitoring the applications and so on and so on. And it used a typical Java-based application, and it did use a certain the third-party plugins for the the interactive charts and maps and other things. It's a very aesthetically represented UI that we need to build. And it also had a couple of RESTful web services in order to talk to the the databases in-house, okay, within that, because we know it for sure that this guy is going to come back and ask us for the scalability in future. And what do you think about it? Does this scale in any sense? You know the answer. Okay, so after a while, after that, the customer base started growing because it's a startup company. They started addressing multiple customers. They're slowly expanding, and government come with a lot of regulations, and then they also started supporting these kind of companies to encourage them to go and promote these kind of programs across UK. And then the customer come back and say, look, you know what? I think looks like there seems to be some problem. Sometimes when we access the application, we are not getting the application available, or maybe that the application is very slow, or because it has to run a lot of intelligent algorithm that it runs in order to generate an alarms. Basically, whenever that device, the PV, the solar panel, hasn't generate to the designed output versus the actual output. So we need to run a lot of algorithm which will basically tell us there is something problem with the device. For instance, if a given device has to generate 10 units per day, for example, and if the device reports 3 units consecutively for last 3 days, so if the sun in that particular region is much stronger, so ideally it should have generated close to 8 to 10, but it's generating 2, so there should be some problem. So this particular customer has to debut a person to go there and then check and all stuff. So through that application, they've been monitoring it. Now we looked at it and said, okay, you don't want to invest further, so you wanted to look at the additional capabilities to be built on. Why don't you increase your hardware resources, meaning load your resources with the high-end processor and stuff like this. So we added a couple more CPUs and RAMs and other capacities so that it could run much faster. It could serve more customers and so on and so on. So they were happy. They said, okay, look, and so that there's no code changes, not much. We still haven't got to the point of looking at the software design and other things. We've been still trying to live with what we have in terms of the resources. So this particular technique is called vertical scaling. It's scaling up, typically in a scalability world of business. And then again, after a while, they came back. Naturally, the business is growing, and they said, oh, look, I'm saying some challenges because I'm not able to get the data or served in time back again. Again, the same performance issues, other related issues, and they also had banking, the billing process has been generated and so on and so on, and they wanted a very specific reporting to be generated, various kind of reporting, like a historical forecasting report, like if I stand today, next year what will happen, how much energy that I would produce, which means how much money I would be able to earn if this pattern continues, and so on and so on, those kind of stuff. So then we looked at it and said, okay, so are you willing to invest more money? Yes, they said, because they made a good progress in the business, armed with the confidence that they said, yes, we are willing to go, but slowly. So we separated the database and the app server and said, look, now you go for it. Okay? After a while back again, they came back again. And that point in time, they said, look, my user base is exponentially bumping up. Now you have to do something about it. And I don't think with a living infrastructure I could do that. I said, oh, look, indeed right, and we can implement a load balancer, and we could add more servers, app servers, and then more clustered databases. And one could be for historical, one could be for archival, one could be a real time, and so on and so on. So we built a kind of a approach here, and which basically represented something like this, from here to there. Okay, and this is called as horizontal scaling. So after this, all the customer architecture looked something like this. So it still remains the same, and there are so many boxes, and in the process, because they keep adding for different purposes, and you know, they're scaling up and as well as scaling down horizontally, and in the process, they overall IT system look like this as well in terms of the, you know, overall business interactions. So while doing this entire exercise, okay, there could be a question popping up. Oh, look, did you take your customer for a ride? Truly not, actually. We could have done this the best possible approach in a very first in a time. We could have told the customer, but it comes with a cost, because the customer is one side unwilling to invest so much money because he doesn't know how his customer user base is going to grow. He doesn't have any clarity. He has a plan, but it has to align with the reality. So he just doesn't want simply invest on things and then, you know, not able to look or make our way out of it. So cost being the one of the crucial element in terms of this overall process. So we understood that cost always continue to be, no matter in any engagement that we deal with, we need to keep in mind in terms of designing or recommending or architecting any particular scalability suggestions out there. Then become the timeline, because they were worried. Look, if I bring additional hardwares and other things, so they need to procure, you know, first of all, they need to procure hardware, and then they do not know what sort of a technology that they need to deal with, and then there are additional resources that they need to deploy in order to maintain those things, and so on and so on. So, and they felt that, you know, we might take more time to implement the entire solution because we are bringing clustering and other things, and so on and so on. So it was altogether a new thing for them. So they also worried about the data. So they said, look, you know, you will distribute the data, and can I always guarantee that the right data is being presented to my customer, and those kind of stuff, because you need to provide the personalized billing report, which is very, very critical. You know, something like, you know, I subscribe to this model, and on a daily basis, I would like to understand how much energy consumption or energy generation is happening across. So that is something, you know, I would like to see that. Maintainability, manageability, of course, it becomes one of the crucial elements out there. Tools and technology, because there could be a lot of new things would have been introduced. You know, I would have said, look, my customer would have been more inclined towards Microsoft. What do I do? And there could be a limitation with that particular technology. So should I use Java? Should I use PHP? Or should I use Python? And how do I choose that? And then what is the additional skill and other things that needed, and other investment needed in terms of the licenses and so on and so on. So that was really, really difficult for us at that point in time. Growing data, definitely. The data has been exponentially growing because we are accumulating a lot of data, and the data has to be presented in a timely manner for a right, user. And that was very critical. And they were increasingly become paranoid about the way that we were looking at extending the architectures, you know, with the added complexities. So out of that, design requirements. So what do we look at it, especially move? So out of this whole exercise, so we understood that any scalability solution that you would suggest, potentially, need to make sure that it increases the performance, not decreasing the performance, okay? By adopting several techniques, like, you know, you could bring in caching techniques or a replication techniques and so on. So you need to use it very consciously, okay? Whether you go for a cluster caching, or you go for a distributed caching, or you would adopt any, the language supported, for instance, Java caching, and so on and so on. Low latency. It's very important that in adding more server or adding more components at the server level would not impact the latency, which means the ability to the response throughput, which is very critical back again. And high reliability. Okay, so people should be looking at that, whether I could rely upon that my data would be retrieved all the time at any given point in time. Dynamic, so it should scale as your user base grows, as your data grows, that you still continue to grow along with that, and so that your architecture and design should allow. It's very brittle, and it doesn't allow you, wherein you go back from where you started and then you redesign the whole thing and then rescale the whole thing. That's not acceptable. operational efficiency, so round trip presentations, of course, it's related to the performance to a large extent. Low cost, and you can't ask me to continue to invest so much money into this, and that's not going to be affordable. We need to find mechanisms and ways that you could adopt, not just always investing the money. Yes, you should invest the money in order to add additional hardware, but that's not the simple solution all the time you look at it. And manageability, I should be able to manage this. Don't come and throw me something that I cannot manage, wherein you tell that I design a solution, but you need to take care of it, wherein I do not know how to manage that. So that's one of the critical feedback that we have learned out of this exercise. Okay, so another interesting observation that we have understood out of this exercise was that the scalability is not meant for just the server. Of course, it can be done on the server. The scalability can be adopted at several layers. You could adopt at the client layer, you could adopt at the app server layer, you could adopt at the database layer. In fact, the database is a very interesting part. I'll come to that later. In client side, let me talk about, we used something called Jcache, not the typical Jcache that you would have familiar with. There's something called, Jcache is a small plugin, and which works with an Ajax control, because we were using highly interactive maps and charts and so on. So it was heavily driven by Ajax and JavaScript. So we used something called Jcache. It's a small J basically, and it's a plugin which basically allows us to, sets the number of connections that I could generate, and effectively it could manage my scalability requirements basically, which is configurable in fact. And app server, at the app server level, we used Java caching system, which is directly supported, Jcache. And we also leveraged the JBoss server. JBoss has its own caching mechanism, because the app server has been clustered and worked in a load balance environment. You don't have to reinvent the wheel by building extras. So the JBoss provides a special caching mechanism which you need to leverage in order to achieve the scalable requirements. For example, we cached all the frequently accessed objects. There were a lot of objects that we've been referring to for every time the alarms and the false has been generated at the server level, because there is an ongoing algorithm runs. It's a daemon basically. It's keep running. The alert has to be shown in a real time for us to be able to capture and act on it. Utilized fully transactional features for a concurrent data access. So especially you implement a mechanism, so you don't create individual connections on your own. Use connection pool or pooling mechanisms which would have been provided by these servers, could have dramatically improvised the scalability need. Implemented a cluster caching, definitely part of that, supported by JBoss cache. We also have looked at cache, which is the distributed caching. Distributed caching is much smarter in comparison to the cluster caching. The cluster caching is a little expensive, simply because it could be an approach depending on your choice. You need to make it. And initially we implemented this because we were evolving with the customer. And the cluster cache basically replicates the data. It mirrors the cache data across. It's the same data being mirrored across the different servers, and then be able to retrieve. Even one fails, it would be able to pick up the other cache from the other available server in the cluster. Whereas distributed caching, it's a fragmented data, and it throws up, it distributes the data, wherein that way it effectively utilizes the memory, other hardware resources, and that's the beauty of it. And I strongly recommend you to use that part of your design. And we used heavily connection pooling. We also used several kind of a pooling techniques like a thread pooling, and especially if you are using servlet, avoid using single servlet model, and it's not good for scaling. And I'm sure every Java developer out there would agree with that. And use more multi-threaded model. And we also used RESTful web services. And when a choice between synchronous and asynchronous, always go for asynchronous. And unless and until your business case directly demands that you should go for asynchronous, wherein you don't want to wait. You need to wait until you get the data, and that's synchronous. And then versus it's okay, you throw that and then you go and do the rest of the things, and then you get the response, you act on it. So that will be much more smarter versus the synchronous. But apply your own conscious decision making process out there to make that. But asynchronous will scale largely, easily.